Everyone, welcome to the Student the Brand. This is your Shiva sir. Today we are going to discuss about magnet effects of electric current. So magnetic effects of electric current. Magnetic effects of electric current. So here we can see magnetic effects of electric magnetic effects of electric current. Magnet effects of electric current. So that is about the topic. So in this topic, we will discuss about the magnet. So magnet is the material, magnet is the substance which attract the magnetic materials. So it has a property of attracting or repulsive. Okay, magnetite. Magnetite is the natural magnet. Magnetite. Magnetite. Magnetite is a natural magnet or lodestone. So it is a natural magnet. It occurs from earth crust. Occurs from earth crust. So here there are two properties. One is attractive property. Another one is directive property. If you are taking magnet has two poles, north pole and south pole. Magnet has two poles, north pole and south pole. So this is a natural magnet. It occurs from earth crust. So naturally it occurs. So that is about magnetite, or also we can say lodestone. Lodestone. Yeah, as I said, so it has two properties: attractive property and directive property. Attractive property is nothing but, as I said, magnet has two poles. So if you are considering this the bar magnet, I am considering bar magnet. So here is the natural magnet is magnetite. There are artificial magnets also there. So those are made by the humans. So those are artificially made. Those are called artificial magnets. Example: bar magnet, dumbbell shaped magnet. So U-shaped magnet. These are examples. So here I am considering the bar magnet. So bar magnet. So north pole and south pole. This has two poles, north pole and south pole. North pole and south pole. So magnetic poles have equal strength. Magnetic poles have equal strength. Okay. Magnet poles have equal strength. So here you can see, wow, these two poles, north and south, has equal poles. Equal strength will be there. Equal strength will be there. So attractive or repulsive will be there. Equal strength. So here the magnetic strength will be more at the poles there in the middle. So here the attractive property. If you drop this magnet into the sand, so dust particles are magnetic materials. The magnetic materials will attract. Magnetic materials will attract at these poles. Magnetic materials will attract at these poles. Magnetic materials will attract at these poles. At these poles, because it has equal strength. Equal strength. Okay. So these are the magnetic poles. So here a less strength will be there. Less attractive poles will be there in the middle. So magnetic field, magnetic property will be there more at the poles than in the middle. Okay. So as I said, poles have equal strength. Poles have equal strength. Now, if you break this magnet into two parts, again it has, if you break the magnet into two parts, again it has, so if you are considering small pieces, again it has two poles, north pole and south pole. Again north pole and south pole will be there. Okay, so each and every piece of the magnet has two poles. At the same time, two equal strength. Poles have equal strength. Okay, so now we'll see that one. North, north will repel. North, south attract, attract. and north also will attract. So south repel. Okay, repel. Understood? So this is about magnetic properties. So north repel, north south repel. So north south. Here you can observe by observing this one, two similar poles, similar poles, repel, dissimilar poles, dissimilar poles, dissimilar poles will attract. Okay, similar poles will repel, dissimilar poles will attract. So that is about attractive or repeller property. And next one, if you suspend the magnet freely, if you suspend, it always shows north and south direction. So exactly it won't show. So I'm considering like this: north, south, east, west. So if you suspend the bar magnet freely, so always it shows north and south direction, somewhat tilted. So exactly it won't be like this. So somewhat tilted portion. Okay. Yes. That's a directive property. The next one, around the magnetic field will be there. So I'm taking this the magnet. This is the magnet. Okay. Around the magnetic field will be there. Around the magnetic field will be there. So up to certain range only, the magnet will attract the magnetic material, or the magnet will influence the other particles. So within this region only it will attract. Within beyond the region or certain up to certain region only it will attract. So I am not only considering this region. So certain range only this magnet will influence the magnetic material up to certain range. Beyond the point it won't attract. Okay. So the region in which the magnet will attract the magnetic material or the magnet will influence the magnetic material is called magnetic field. So this is the magnetic field. So this is called magnetic field. Clear? So the magnetic field will be in the form of field lines. The magnetic field will be in the form of field lines. So the field lines will be there. So now we will see how the field lines. So the magnetic field you can observe. Okay, the magnetic field. So so around the bar magnet. So I'm taking this a bar magnet. Okay, so north and south. So the magnetic field will be starting from north and reaching to the south. So I'm considering like this. Okay, so here you can see the magnetic field. So the magnetic field will be in the form of field lines. I said the magnetic field will be in the form of field lines. So magnetic field starts from north and reaches to the south. Okay, in the form of field lines. So here the more magnetic field will be there. So at the poles. Okay, so it reaching to that one. Here properties of the field lines. What are the properties? Properties of magnetic field lines. So we'll discuss properties of magnetic field lines. magnetic field lines. First point is, so magnetic field lines start from north and reaches to south. Second point is, these all are closed loops. So loops, closed loops. These are closed loops. Outside of the bar magnet, is magnetic field will be from north to south. Inside of the bar magnet is south to north. Outside of the bar magnet is magnetic field will be north to south. Inside of bar magnet is south to north. Okay, so these field lines never intersect. These field lines never intersect. So field lines never intersect. So here if you are taking like this, so these field lines never intersect. So if it intersect, what happens? Compass should show at a time. So how the direction of the magnetic field can be found? If you draw the tangent, so along this direction, at that point, at this particular point, the field direction will be there. Okay. So if you place the compass, it shows the direction. So if these two lines intersect, so magnet compass should not show two direction at a time. So that's why, so these magnetic field lines will not intersect. Okay, that's the concern. So that is about magnetic field, bar magnetic field. Next one, so we'll go with that Oersted observation. So what happened? Oersted observed. So a current carrying conductor placed near there. So magnetic compass is placed near current carrying conductor. Then what happened? Suddenly the magnetic compass shows the deflection. So by that we can observe. So if the current is passing like this, so if you place the compass is also a small magnetic needle present over it, inside of it. So it is also small magnetic needle only. Okay. So when the current is passing, this magnetic needle shows the deflection. Okay, suddenly it shows the deflection. Then so or should observe that. So there is a relation between current and magnetism. Okay. So later so many inventions are came. Okay. So that's about. Next one. If you are taking the straight conductor, I am considering straight conductor, current is passing through it. So if you are taking the straight conductor, so this is a straight conductor like this. So here if you see, this is straight conductor. Here we can say rheostat and ammeter, rheostat, ammeter, so battery. Okay, so now current is passing, positive, negative, current is passing. So this is a straight conductor. This is a straight conductor. If you place the wood like this, so cardboard, if you place like this, if you place the cardboard, if you sprinkle the iron particles over it, iron particles, so around the current carrying conductor, so around it here if you take, so around this conductor, the more magnetic field will be there. So what it represents, so current is passing like this. Okay, so when the current is passing like this, so the magnetic field will be here at near the conductor. So first point, near the conductor, the magnetic field will be more. So the magnetic field lines are more crowded. So it represents, so the field lines will be more. Here the field lines will be more. It represents magnetic field will be more. So when you are moving away from it, the magnetic field will be less. less. So it depends on distance also. Okay, so when near to the conductor it will be more. When you are moving away from the conductor, the magnetic field decreases. The magnetic field decreases. So here if you are placing the compass here, the magnetic field direction will be, so the deflection will be towards, if you are considering north, south, east, west, so the deflection towards west. If you change the current direction, so initially the current is moving like this, if you change the current direction like this, so the compass shows towards east direction, the deflection shows towards east. Okay, so by this observation we can conclude that if you change the current direction, magnetic field direction also changes. If you change the current direction, magnetic field also changes. If you change the current direction, magnetic field direction also changes. Clear? So that is about straight conductor. And so we can see that. So how we can find out the magnetic field? How we can find out the magnetic field? By using right hand thumb rule. So this is the current carrying conductor. So I'm taking the current carrying conductor. So I'm holding like this. Current is passing like this. Okay. So if you are wrapping the fingers, along the folding fingers, the magnetic field will be there. So like this, the magnetic field will be there. So this is the current carrying conductor. So if you are considering like this, so here, so the magnetic field will be anti-clockwise. So the magnetic field will be clockwise. If the current is moving downward direction, the magnetic field will be clockwise direction. Okay. So if the current is passing upward direction, so the magnetic field will be anti-clockwise direction. Okay. So like this we are considering. So this is a clockwise, this is anti-clockwise. So that is about, by using right hand thumb rule, we can identify the magnetic field direction. By using right hand thumb rule, we can identify the magnetic field direction. So if the current is passing like this, so the magnetic field will be downward direction. If the current is passing like this, the magnetic field will be upward. So like this. Okay. So it depends. So when the current is passing like this, the magnetic field will be upward direction. If the current is passing in this direction, the magnetic field will be downward direction. Okay, so I'm taking upward like this. So if you are considering like this, next, so we'll go to the loop. So we are considering the loop. So this is the loop. So current will pass here. Okay, the magnetic field will be here. And here also the magnetic field. Okay, so when keep on going, so if the current is passing like this, the magnetic field will be like this. The current is passing, so the magnetic field will be like this. Okay, so when you keep on going, so keep on changing. So here, this is north and this is south, because from here the magnetic field is leaving. So you can observe the magnetic field is leaving. So it's moving like this in downward direction. So magnetic field is leaving. So to this side magnetic field is reaching. That's why it is south, and this is north we are considering. And so here you can observe. So so here the magnetic field will be here near to the circumference, it will be there. When you are moving near to the center, this magnetic field become parallel lines. So what happens? So this magnetic field will be added to this one, this magnetic field will be added to this one. So more magnetic field will be there at the center. So the magnetic field will be more. So at the center, so the magnetic field will be added. So here this line magnetic field will be added, this line will be magnetic field. So one magnetic field will be added to another one. Then So here it will become uniform magnetic field. The magnetic field will be more at this center. So the magnetic field will be more at this center. Okay. So this is about loop. That is about loop. So here this is the circumference. So here by using right hand thumb rule only, we can identify the magnetic field direction. So if you are taking this magnetic field current direction, actually current is passing like this, right? So if the current is passing like this, by using right hand thumb rule, we can identify the magnetic field direction. So when keep on the magnetic fields here, you can see at these positions, at this point, the magnetic field lines become parallel. The magnet is at the center, the magnetic field lines become parallel. So as I said, so this magnetic field will be added to this one, this magnetic field will be added to another one. So what happens? So one on one it will be add up, then at the center it will become uniform magnetic field. So the magnetic field will be more. So the magnetic field will be more, the magnetic field strength also will be more. So here I'm considering this is one phase. So to this loop, this is one phase. So this is one phase, and another phase also this side is there. So to this my hand, so this is one phase, and back side also phase is there. So this is one phase, this is one phase. So like this. So to this loop, this side is one phase, another side also another phase will be there. So one side it will act as a one pole, another side will be a different pole. So based on the current direction, so the phase will be identified. So how we can identify? By using clock phase rule. By using clock phase rule, we can identify the side. So I'm considering this is a if the current is passing in anti-clockwise direction, that phase is called north pole. And if the current is passing clockwise direction, that phase acts as a south pole. So if the current is passing anti-clockwise direction, current anti-clock north, current direction clockwise, that is south. So these are very, very important. So keep in mind. So if the current is passing anti-clockwise direction, that phase is north. If the current is passing clockwise direction, that phase is south. Clear? So next one, solenoid. So those who want, you can note down. So basic points. So you can know these points. Next one, solenoid. We'll discuss about solenoid. Solenoid, very, very important. So 2 marks question in CBSE grade 10 physics. Okay, CBSE grade 10. So this is about CBSE grade 10 physics. Okay, solenoid means, so if you are taking the straight wire, as I said, if you are taking the straight wire, so current is passing, we can identify the magnetic field by using right hand thumb rule. We can identify the magnetic field direction. So whereas if you are taking the same wire and bent in the form of cylindrical shape, so if you are taking the bent in the form of cylindrical shape, that will become solenoid like this. So like this I'm considering, and here also. So current is passing like this. So switch, current is passing. I'm considering like this. Positive terminal, negative terminal, current is passing. Okay. So inside of the magnetic field, inside of the solid, current is there. Current is passing like this. Okay. So here magnetic field will be produced. Magnetic field will be produced by using 1, 2, 3, 4, 5, 6, 7, 8, 9 lines I am taking. So one line I am considering like this. 1, 2. Okay. So here I am considering either you can take this circuit diagram inside or circuit diagram outside also fine. That is your choice. Don't overdraw. So positive, negative. So here the magnetic field will be here. You need to understand current is leaving. That's why I'm placing this side is south. Current is moving towards that. That's why I'm placing north. Okay. Then magnetic field should leave from this pole. Okay. So inside of the wire, the magnetic field will be uniform. Here you can see at every point in this place, the magnetic field will be uniform. The magnetic field is uniform. The magnetic field is uniform. The magnetic field is uniform. Second one. So at every point, so here, at every point, the magnetic field is uniform. The magnetic field is uniform. Outside of the solenoid, the magnetic field is not uniform. It is non-uniform. Here, some field will be there. Here, some field will be there. Here, some field will be there. So here, the magnetic field is not uniform. Only inside of the solenoid only. Inside of the solenoid only, the magnetic field is uniform. Magnetic field is uniform. Okay. So same it act as a bar magnet. However, it is bar magnet. So solenoid act as a bar magnet. Solenoid act as a bar magnet. Bar magnet. So here north pole is there, south pole is there. Magnetic field will be created. Even if you suspend freely, it shows north and south direction. But here the difference is the difference between bar magnet and solenoid is here. So I will explain the differences. Here I am considering the bar magnet, and here I am considering the solenoid. Here first one, poles are fixed. So this is what we consider bar magnet, north and south. Here poles are fixed. So N and S are fixed. But here by changing the battery connection, so here current is moving like this. So if you change the battery, if the current is moving in this direction, poles will change. Poles can be interchanged. Interchange. Okay. So here strength will be fixed. Strength is fixed. Here strength is fixed. Here strength is not fixed. Strength is not fixed. By changing, see, more number of current passes, magnetic field will be created more. And the number of rings, if number of loops are there, if 1, 2, 3, 4, 5, 6, like that 6 loops are there, if you increase more number of loops, so the magnetic field will be more. Okay, so it depends on, here I am considering strength is, in bar magnet it is fixed, we can't increase, whereas in solenoid the strength can be increased by increasing the current, by increasing the number of turns, number of loops, and also the gap between the loops also. Gap between the loops, if you increase, automatically the magnetic field will be more. It will reaches to the more magnetic field. It attract the magnetic material little more strength, little more area. Okay, so depends. Next one, that's enough. That is about bar magnet and magnetic field. Okay, that's enough. So if you have any doubts, you can ask. Then next one will go with the electromagnet. Electromagnet means when the current is passing. So here the current is passing, the the conductor act as a magnet. Conductor act as a magnet. Next one, Fleming's left hand rule. Fleming's left hand rule. Fleming's left hand rule is used to identify the force. Fleming's left hand rule. So until here, so I hope you got it. So magnet affects electric current. So one more topic is current carrying conductor placed in the magnetic field. Current carrying conductor placed in the magnetic field. By using Fleming left hand rule, we can identify in which direction the force will act on the conductor. So Fleming's left hand rule is represents. So Fleming's thumb represent force. Thumb represent force, and forefinger represent forefinger represent magnetic field, and the middle finger represent current. So we can say middle finger represent current direction. Okay, so that's enough. Clear? So that's about a Fleming left hand rule. So we can say like this: thumb, force, this one, this is the current, it represents current. So middle finger represents current direction. So index finger represents this one. Index finger represents the magnetic field. Thumb represents the force acting on the conductor. Okay. So this is about what is it? Magnetic effects of electric current. So if you like this course, CBSE grade 10 physics, CBSE grade 10 physics. Okay, so all 4 chapters: light reflection and refraction Second one, human eye and colorful world. Human eye and colorful word. And the third one, electricity. And the fourth one, magnetic effects, electric current. This 4 chapter explanation will be given. These 4 chapters explanation will be given, and the soft copy notes will be provided. The soft copy notes. Okay, you'll be getting soft copy notes. Soft copy of my handwritten notes. Will be getting. Okay, so with the cost of 500 rupees and 100 definitions will be provided from these 4 chapters, and 100 electricity problems, 100 definition, 100 electricity problems. Okay, with the cost of 500 rupees I am providing. So if you want this course, you can contact to this number. So I am providing this number 9849812804. Okay, you can contact to this number. So WhatsApp is there. Those who want this course, 9849812804. So with the cost of 500 rupees. So I'm providing this course. Explanation will be given. Doubt clarification will be done through live classes. Okay, and interactive session will be there. So if you have any doubts, support will be there. Okay, and we'll be also getting soft copy notes. Will be on my handwritten soft copy notes. You'll be getting. So if you want, you can call to that number. So this is our this is about CBSE grade 10 physics, and this is Vasavasa. Thank you so much. If you like this video, so please do like, share and subscribe to Student the Brand. Do subscribe. please do subscribe my channel Student the Brand. Thank you.